There we go. Should I record it? That way I can upload it later. 2.3. Solving linear equations. If you remember solving equations, this should not be too bad. We'll go over it from the basics. Okay. Different pens are running out. Negative 3x plus 4 plus 5x is equal to 2x minus 3x plus 8. Okay. So first thing you should do is combine all like terms and then start doing the parentheses. Right? It should always be parentheses first. But we can do one side separately at a time. So let's focus on this side. So notice we have a negative 3x and a 5x. So add those together. What is minus 3 plus 5? And then we keep the sign of the bigger one, right? So we can just combine those guys. Now on this side, we have a minus on the parentheses. You're gonna have to distribute negative, negative. So right there, it's gonna be a negative 3x minus 8. I left the spacer for no reason. I just want to put the equals in the same spot. It doesn't matter. Anyway, 2 minus 3. Will that be positive or negative? I always keep the sign of the bigger one, and the bigger one is 3. So it'll be a negative 1, right? Negative x. So make sure we get those signs right on the exam. Pretty sure the mistakes I'm going to find are sign errors over and over again. So try to get that down. But I know it's going to happen. We'll get it little by little, right? At this point, we did the parentheses. Combine like terms. So now the point is get all the x's on one side. It doesn't matter what side you choose. You can move them on the left or right. Most people move them to the left just because there's no reason. So at this point, so let's see, from here to here, distribute negative. All right. So I'm going to add x to both sides. So basically what's happening is you have a 2x plus an x plus 4 equal to, these are gone, right? They're 0. If you want to see it, it'd be just this. 0. 2 plus 1. So from here to here, add x to both sides. Now, I think I told you last time that if you want to think about it just moving it over the other side, you can. So I'm moving the negative to this side, making it plus. Right? That's fine. So plus 2 plus 1, 3. I'm going to move this 4 over there, which is a minus 4. I think it's a little easier, but that's up to you. I don't care how you think about it. So one of the only places we're completely free, right, are our own minds. So negative 8 minus 4. Yeah. Negative 12. There we go. So from here to here, technically the math operation is subtract 4 on both sides. So the final step, what do we do? Divide by 3, right?
So -4.
-4. Right, because it's negative divided by positive, so it stays negative. Let me see if any students showed up via Zoom. I don't know if people. Did I see? I guess they just failed. Anyway, it's all good. So, any questions on any of those steps? That okay? You're allowed to use your calculator anytime you want. I'm not going to force you to use one thing or the other. So if you want to use this, you can. Like for the next one, we got a bunch of fractions. So either we cancel them, find LCDs, or use your calculator. Those are your options. You guys are cool on number 1?
Yeah.
Okay. Number 2 has a bunch of fractions here. Okay. So remember, think of each side separate and go through the order of operations. Left to right, we're supposed to do the parentheses first. That has the highest priority on the PEMDAS, right? Please excuse my dear Aunt Sally. Parentheses is first, P. So distribute your -3. That will give us -6 plus 15. -3 times 2 is negative. -3 times -5 is positive, right? Over here, we got these lame fractions. I want to put the fractions together, just so you can see that these need to combine. Now, if you want to use this, we'll go ahead and use it this time. Why not? We're going to add 1/8 plus 1/4, right? So the commands to use this, there's a fraction button right here. 1/8 plus fraction button 1/4. So if you have it in math print, it'll give you the reduced fraction automatically. If you go to mode, see how it says math print? So it'll always be the reduced form, even for square roots too. They can save you some work there. So 1/8 plus 1/4 is 3/8. So this is really 3/8. But now here we have 2 like terms, 4 plus 15. Let's put the x first. That's going to be 19, right? Now this one, you have to get all the x's on one side, all the constants on the other, so we can get to the division part. So let's move this guy over there, and this 19 over here. So I'm just gonna do it in 2 steps. So I move the fraction to -3/8. Then I'm gonna move the 19. In 2 steps. Is that okay? So technically I subtracted -3/8 x on both sides And then from here to here, subtract 19 on both sides. I'm gonna try to write the steps, so if we look at it later, we know what happened, right? All right. So now we have a -6 minus a 3/8. So we can use our calculator if we want. But if you use minus negative symbol, you gotta use this button. Don't use subtraction. If you want to use a negative number, you're gonna get an error if you do. So -6, then you put minus the fraction. That fraction is negative, but I already put minus, so that takes care of it. So 3/8 to be -51/8. So not pretty at all. -11 minus 19, what's that gonna be? Yeah, -30. Okay. Any questions so far? Is that okay? Is that not too bad? Okay, so we gotta get rid of that weirdo number, right? So same thing as before, divide by whatever's there. It's just that dividing is a fraction now, so life sucks a little bit, it's all good. So divide this by this guy, same thing. Divide this by this guy. So these are gone, right? Who cares? So you divide by the exact same thing to cancel it. So you don't have to really think about that part. X is solved for. Now we just got to get this result here. You could do it in your machine, but you should also note that this is equal to -30/1. Right? You flip, remember we said when we do the fractions, you flip and multiply. So I'm going to flip by the bottom one. But now I have -8/51. So you could multiply straight across if you want to. Negative is positive. Or you can use your machine, which I'm going to allow you to use. So I have a -30 divided by a fraction that is -51/8. So yeah, that would be positive. So if you were to multiply across and reduce, you're going to get this guy. Okay. So 80/17. So this will be our answer. Anyway, but that's how you would do it if you were going to do it by hand, like we showed at the beginning, you remember? Fraction review, chapter 1. All right. Any questions about any of the steps? Anything anywhere I lost you, or you spaced out and missed it? I mean, I won't take offense because it happens to me all the time.
Yeah.
I'm really bad about it, so I won't feel bad if you do the same. You guys good then? Just let me know. Anytime you're like, you know what, I don't know what the hell you're talking about at the beginning, can you start over, or can you tell me that first step again? That's okay. Don't feel bad asking. Okay. Let's move on to example 5 then. Number 3 is just the same thing, but with decimal numbers. Who cares about that? Example 4 is similar to number 1. So let's do number 5 on your workbook. So on these, it's gonna be possible that there is no answer. So you'll get something, whenever when you have an equation you're solving, and you get to the last step, and you get something that is false, like 7 = 4, like obviously that's not true, right? Any kind of false statement along the way, I don't care what it is, once you see it, you say there is no solution. Okay, so if the x's cancel out and you're left with a false statement, that's when you're going to say no solution. In the book, they want you to write the symbol, the null symbol, which I'll show you in a second if you haven't seen it. You write the instructions this time. Solve the following. Use the empty set symbol for no solution. And this notation, you're familiar with this notation? This says X, and then I have a little line in front. That means such that X is a real number. So if you have a true statement, but no X's anywhere, if you end up with 5 = 5 or 0 = 0, then there's an infinite number of solutions. So you're going to say this. If you end up with false, you're going to say this one. Okay. All right. So on the left side, you see X's that combine, right? So 6.3 minus 8, what is that going to be? It's going to be negative. See, the 6 minus 8 is -2, right? So nah, you're good, man. You're good. I'm still trying to wake up.
Yeah, I'm over multiplying that extra.
I had a long day yesterday. I feel that. I was teaching not a 9 p.m. class yesterday.
Oh, wow.
That's horrible. But I was working since, but I also had an 8 a.m. class. So I was teaching all morning, then there's a break in the middle, and then teaching all night. So I'm like, oh, this schedule's stupid. I don't know why I chose this. But it's on me, I guess. Didn't think about it. Didn't think about it. So forgive me if I'm a little tired sometimes. We're out of it. Okay, so 1.7x minus 10. That part's good, right? Distribute the 5. We got to do the distribution first. So -5 times 2. -5 times 0.1.
Negative or what would be 0.10? Negative.
I
No.
think it's 0.5 maybe? I don't know. I've done decimal. Let's find it.
5 times 1 is 5.
Let's see. Yeah. I haven't done decimals in my head in a while. There we go. 0.5x. Okay. So we got our numbers now. Oh, it's plus, my bad. Negative times negative is plus. You don't have to write 0.5, you could put 0.5. It's up to you. Not gonna get mad at you about it. Only people that get mad would be like if we're in a lab doing experiments or something, then that type of stuff matters. Right now it doesn't matter. So combine your like terms. You got negative 2.2 plus 0.5. What is that going to be? It's the other direction. Yeah. All right, so 5.5 minus this,
Yeah, oh, yeah.
right? Okay, there we go. Now notice, what do you notice right now?
It's the same.
Yeah, as soon as you see that, you should stop. I mean, you can keep going and it's just gonna stay the same no matter what. Although, if you keep going, there's a chance you're gonna F it up. So as soon as you see this, just stop and say, you know what? Oh, any X works here. So no matter what X you choose, it will always stay the same. It will always be equal. So you say this, all real numbers. So you got the true statement on both sides, the exact same thing. Because as soon as I add 1.7, they're going to cancel, right? Then if I add 10, that's canceled too. So then I get 0 equals 0. And like, no matter what you do, you're going to get the same thing. You can add 2 to both sides. You can keep getting equality. Just stop.
So then the answer would be 0.
You'll just say this, X is, the answer would be whatever you want it to be. You can just add whatever you want on both sides. It'll just be equal to whatever you have. So once I get to 0, right, I could add 5 again and have 5 equals 5 for no reason. You can keep doing that forever. So that's what I'm saying. As soon as you see that it's the same thing, just stop and put this. Any X is going to equal, right? Another way to write it would be X is an element of R, all real numbers. Okay, but if you get a false one, then you also stop. I think the next one might be false. Let's see. But does that make sense for 5?
Yes.
3x minus 4 equals 21x minus 5. Okay. So let's distribute the 7. We're going to get 21x minus 28. Distribute 7. Then right away, you notice we have the same X on both sides. That's a hint that they're going to cancel out. But let's try to work it, right? So if I subtract 21 to this side, I'm going to get 21x minus 21x minus 28 equal to minus 5. So subtract. $21 on both sides. So at that point, it's gone. You're going to get negative 28 equal to negative 5, right? Let's move it over there. These are gone, right? So what do you notice at this point? There's no more x's, right? Is negative 28 equal to negative 5? Yeah, there's no solution, so you would just write or no solution. So just stop at this point. As soon as you see something that is false, don't do any more work. Any questions on 5 or 6? So there's not always going to be an answer. Sometimes the answer is any number. Sometimes the answer is no number. No solution. Do one more and then we'll move on to the next section, I guess. 4x plus 5 is equal to 3x plus 5. Just going to write false statement right there. Forgot. Okay, so subtract 3x on both sides. You're going to get 4x minus 3x. Then we get x plus 5 equal to 5. Subtract 5. We get x equals to 0. Is that a problem? No, it's not weird, right? It's just an answer. X is equal to one specific number. Over here, we had no answer. And then the first one, we had any answer. So those are the 3 possibilities. Whenever you're solving any equation, either you have one unique solution, no solution, or infinite number. That's it for 2.3, I think that was. Are there any questions on 2.3? Let me look at the schedule, but I forget. That whole freeze stuff's thrown me off. We are on your week. I see. So we're behind a little bit. Not a lot, though. But technically, we should be reviewing for test 1 this week and taking the test. But we're not going to do that. So we're going to push that back a bit. Test 1, we'll review for test 1. We'll start once we pass 3.4. So we're not even in 3 yet. So that's cool on that page. All right, 2.7 is the next one. This is the last section for chapter 2. So graph the solution for the following. Okay. So in this section, we start talking about interval notation. So what we're gonna do is graph it and then put it into that notation. Okay, so this is saying any x greater than 3. So just go to the number line. Go to 3. Just gonna put it right there. And we keep going this way forever. We do not include the 3, so you put a parentheses right here. So that's the graph. The notation would be, remember, it's always the smallest one first for interval. In other words, either the smallest one or most negative, or the starting point goes first. So 3 is the smallest one, or n actually the starting point, and it keeps going to the right. So you say 3 to infinity. We put parentheses when we don't include it. See how it's not equal to 3? It's just greater than 3. So we start right after 3. Like 3.1 is cool, but not 3. 3 is not included. Does that make sense? So this guy, this x is less than 2, not included. So I'm just going to put 2 right here. So we put parentheses again, and we keep going below 2. The arrow is pointing that way. So just a tip, if your x is on the left side, you can just follow the arrow. Right? If x is over here and the arrow is pointing that way, that's where we're going. But if the x is on this side, then you can't do that. X is less than 2, keeps going. So on this one, it keeps going to the left forever. So you're going to write the negative infinity symbol for this direction. And then the highest value is the second one, which is 2. So think of it as going from way out here all the way until 2. That's what this is saying. Okay. Let's do a couple of these. X is greater than or equal to -4. So this time it's equal to. So I'm putting -4, I guess, right there. So a bracket, because it's equal to. So I'm starting right on 4, then I keep going to the right, this way. So the interval notation would be starting at -4, and then I keep going. That making sense? Okay. So let me give you the picture here. Here's one. And I keep going to the left, right? So what is the interval for this one? What do you think? Yeah. Negative infinity up until when? Yeah. But we put our bracket, right? To give the interval for each graph. No, so here's a graph. Here's pi, and it keeps going this way. What is the interval? Yeah. What about this one?
Negative.
What would be the inequality? You writing it this way with the symbol. I'll do the hard part for you.
Will we with eight actually be less than?
Right? Remember the arrow points this way, right? Yeah, this one will be pi. You talking about this one?
Yeah.
The dollar will be less than that.
Yeah. So since it's bracket, we got to put that line underneath. Make sense? Is that okay? So on the homework, I think they're going to give you, they're going to go both directions. They're going to give you a graph and tell you, hey, what's the inequality? What's the interval? Or they give you the inequality, which is this symbol here. This is an inequality, by the way. They'll ask you to do what we did in number 1 through 4. Okay. Any questions on 5? I'm gonna move on to something else. Graph the solution of the following. So whenever you see this right here, when I first saw this back in the day, that was really confusing to read. It says -3 is less than x, which is less than or equal to 7. Like, well, what does that mean, right? So we got to, the way I would prefer you to think about it would be if these arrows are pointing to the left, then this is just saying x is between -3 and 7. That's it. So the values of x range from -3 to 7, but we include 7 because it has an equal to. This one does not, so it would be a parentheses, right? See what I'm saying? So if you graph this, you would go to 7 and put a bracket, and on -3 you would put a parentheses. Everything inside is great. Does that make sense? And then as an interval, how would you write it? Yeah, what's the lowest value? What's the highest value? Yeah, -3, 7, but we got to put a bracket, right? Oh, forgot about that. They didn't ask us for the interval. But we should practice because they're gonna ask eventually. Any questions on 6? So again, same thing. X is between these two weirdo numbers, -3 and 16/3. Oh, sorry, -2/3 and 16/3. So the number line would just have those two endpoints, right? Somewhere over here is the bigger one. Somewhere over here is the smaller one. All we have to decide is, do we put a bracket or a parentheses? Which one has a bracket? And this one doesn't, right? Everyone see that or no? So that'll just be this guy here. Out of space, so. So that's always going to be that way if the arrows are to the left. If the arrows are to the right, then it's a little different. They might also write it this way. Guys, cool on this page. So X is less than or equal to -0.1, or X is greater than 0.4. So this is the type if they would have put it together, the arrows would be to the right. But the easier way to understand it is to write it this way instead. So I'm glad the problems on here set it up this way. But it could have been the other direction. But anyway, so this is saying that you have a number line. So let's find the -0.1. And 0.4. The 0.4 means you just keep going this way, right? To the right. That's what this is saying. You see what I mean?
Yeah.
So the parentheses, it says X is greater than 0.4. So everything bigger than 0.4 is on the graph. This one's saying everything below or less than or equal to -0.1, right? So we're gonna put a bracket and go below. Wait a second. Okay, so now the idea is, how do you create two intervals, right? But you have two separate ones, they're no longer together. See what I mean? So let's just do them separate. So this one will be negative infinity up until negative 0.1, right? And then this guy will be 0.4 until infinity. All you got to do is put a union symbol. Does that make sense? Do you see how to do these? So yeah, this is the union symbol. It's like a big U. You guys remember that? Or no? So union this section and this section together. That's it. Already. Let's move on to number 10. You guys cool on 8, right? Let's write a little note. That's the union symbol. Okay. Write the solution in set builder notation and interval notation. So here we're going to do both types. So we're going to practice the interval again, which is this one. We've been doing that for a while now. But we're also going to do the set. Put number 10 down here. So x is less than or equal to negative 4.5. If it helps to make the graph, then go for it. Doesn't matter to me. If you don't want to, that's cool. They didn't ask for it. Bracket because it's equal to, and we keep going to the left. Right? Now the set builder is going to be this one. So x such that x is less than or equal to negative 4.5. And then the interval notation, so this is set builder. Wrote that out, messed up. And then the interval would be this one. Any questions on 10? So same instructions. Negative 3 is less than a, which is less than 2. So the set builder will be a such that a, oh, actually, just write the symbol. A is between 3 and 2, but not equal to those endpoints. Just in between. That's it. Again, you can graph it if you want, if it helps. You don't, I'm not going to this time. Interval will be parentheses because it's not equal to all the way until the other endpoint. Anyway, I think that's enough for 2.7 unless you are confused by anything or did you miss anything? Is it okay? What do you think? 0.7. Okay. How much time we got? About 10 minutes. So we'll stop our lecture here. You guys have any homework problems you're stuck on or anything? You guys doing okay? All right, so next time.
Actually, I have a whole problem.
Yeah, okay. What is it?
I guess I'm one.
What number, what's the problem?
4/5 X.
4/5 X?
Equals 24.
Okay. They just want you to solve, right?
Yeah.
So we can do that in a couple of different ways. Like we showed today, we could divide that by 4/5, both sides.
Yeah, it's get that.
You could also do it in pieces. If you don't want to divide by a fraction, you could cancel the fraction and then divide by 4 if you want. It doesn't matter. I'll show you two different ways. To divide by 4/5 on both sides, cancel this guy, right? So now we just got to deal with this. So it's 24 over 4/5. Well, that's the same as 24 times 5/4. So use your calculator. You can use your, or just reduce it yourself. 4 goes into 24, right? Many times. Let's see, close. 6. So 6 times 5 is 30. So X is 30. If you use your calculator, you could have just done this if you want. 24 divided by the fraction, 4/5. It's up to you.
Yeah, I got stuck after the
This step here.
yeah. That's why I got stuck up. I got it now.
Got any other ones?
Sorry.
Right, so on Wednesday, or sorry, Thursday, we're gonna do 3-1, 3-2, 3-3, 3-4. So try to get caught up because we're gonna do a bunch of them next time. And then I'm gonna open up the exam on Canvas. You can use respondents to take it whenever you want. I'll leave it open for about 2 weeks. I prefer the sooner the better because we're gonna keep going. But on Monday, I will do some review over chapter 2 and 3, just real quick, the whole class period. And then Thursday, we're going to move on to exam 2 material, chapter 4. Okay, is that clear? All right. And I'll try to upload